Bismillahirrahmanirrahim. In this lecture, I am solving problem 5.7 from the book Applied Thermodynamics by McConkey. So, the statement of the problem is calculate the cycle efficiency and mean effective pressure of an air standard diesel cycle with a compression ratio of 15/1 and maximum and minimum cycle temperature of 1650 and 15 degrees centigrade. So first I'll draw the PV diagram for diesel cycle. So pressure and bar and volume in meter cube per kg. Now heat supplied at constant pressure in diesel cycle and heat rejected at constant volume. So process 1 to 2 is adiabatic compression. PV gamma is equal to C, and this is compression because volume is decreases. Process 2 to 3 is heat supplied at constant pressure, and process 3 to 4 is adiabatic expansion, and process 4 to 1 is heat rejected at constant volume in the diesel cycle. This is the PV diagram. Now statement is calculate cycle efficiency and mean effective pressure of an air standard diesel cycle and given data. This is basically air standard diesel cycle, air standard diesel cycle with a compression ratio is defined RV, which is basically V1 divided by V2, which is equal to 15 divided by 1, and maximum and minimum cycle temperature is basically T3. This is maximum. If we look into the PV diagram, at point P temperature, at point 3 temperature will be maximum. So T3 is equal to 1650 degrees centigrade. Convert this into Kelvin, so which is equal to 16 and 50 plus 273 Kelvin, which is equal to 1923 Kelvin. Minimum temperature point is basically 0.1. So T1 is equal to 15 degrees centigrade, which is equal to 15 plus 273 Kelvin. So T1 is equal to 288 Kelvin, and this is T3. And required data is cycle efficiency. Required is to find the cycle efficiency and mean effective pressure, which is denoted by PM. So we start solution. So to find cycle efficiency, we need T2 and T4. So first I find T2. So for process 1 to 2 is adiabatic. So for adiabatic process, from 1 to 2, I can write the equation T2 divided by T1 is equal to V1 divided by V2 whole power gamma minus 1, and this V1 by V2 is basically compression ratio. So T2 is equal to T1 multiplied by compression ratio into gamma minus 1. Per year gamma is 1.4. T1 is basically 288 Kelvin, and RV is 15 by 1. So 15 by 1 is equal to 15. and 1.4 minus 1 is 0.4. See, so T2 is equal to 288. This is 0.4. 288 Kelvin and to 15. So take power of 15 power 0.4 and multiply by 288. So this will be equal to 850.8 Kelvin. Now I am finding T4. So process 2 to 3 is process 2 to 3 is basically constant pressure process. This is basically constant pressure. So at constant pressure, Charles' law is applied, and at Charles' law, volume is directly proportional to pressure. In Charles' law, volume is directly proportional to pressure. So we can write the equation V3 divided by V2 is equal to V3 divided by V2 is equal to T3 divided by T2. It means that V3 is directly proportional to T3 and V2 is directly proportional to T2. This is basically Charles' law. And which is equal to T3 is equal to 1923 Kelvin and T2 is equal to 850.8 Kelvin. This Kelvin will be cancelled with Kelvin, and V3 divided by V2 is equal to 2.26 kelvins. 2.26. This is the ratio of V3 and V2. Now I can write this as to find T4. T4 divided by T3. Process 3 to 4. Process 3 to 4 is adiabatic. Process 3 to 4 is basically adiabatic. So PV gamma is equal to constant. So here we can apply the equation T4 by T3 is equal to V3 divided by V4 power gamma minus 1. So divide numerator and denominator by V2. So V3 divided by V2 is equal to V4 divided by V2 and power gamma minus 1. So V3 by V2 is basically 2.26. T4 divided by T3 is equal to V3 divided by V2 is basically 2.26 and V4 is equal to V1. V4 is equal to V1. So this V4 is equal to V1. So V1 divided by V2 is compression ratio, and compression ratio is given to us as 15 power 1.4 minus 1. 1.4 minus 1 and V4 is equal to V1. So we can write V4 divided by V2 is equal to V1 divided by V2, which is equal to compression ratio. So T4 is equal to T3 and T3 is equal to 1923 Kelvin and 2.26 divided by 15 is equal to 0.15066 and 1.4 minus 1 is 0.4. So T4 is equal to 901.94 Kelvin. Now we can find heat supplied, because heat supplied is at constant pressure from 2 to 3. This is heat supplied at constant pressure. At constant pressure. Sorry, this is heat supplied at constant pressure. P is equal to C. So Q is equal to heat supplied is equal to Cp T3 minus T2, which is equal to 1.005 kilojoule per kilogram per Kelvin. T3 is 1923 Kelvin and T2 is 850.6 Kelvin. So this Kelvin will be cancelled with Kelvin, and heat supplied is equal to 1077.56 kilojoule per kilogram. Similarly, heat rejected is at constant volume. Heat rejected at constant volume. So it's kind of CV, and heat rejected from 1 to 4. So this is equal to T4 minus T1. Cv is 0.718 kilojoule per kilogram per Kelvin. T4 is 901.94. T1 is 288 Kelvin. Kelvin will be cancelled with Kelvin. So heat rejected is equal to 440.808. 440.808 kilojoule per kilogram. Now we know that heat supply net heat is basically equal to net work, which is equal to heat supplied minus heat rejected. So W net is equal to heat supplied is equal to 1077.56 kilojoule per kg minus heat rejected is 440.808 kilojoule per kg. So net work is equal to 636.755 kilojoule per kg, and cyclic efficiency is now equal to net work output divided by input, and input is heat supplied. So net work input is 636.75 kilojoule per kg divided by heat supplied is 1077.56 kilojoule per kg. This kilojoule per kg will be cancelled, and cycle efficiency is equal to 636.75 divided by 1077 is equal to 0.5909. To find it in percentage, multiply and divide by 100. So multiply by 100 mean 59.09, and out of 100 mean percent. So cycle efficiency is equal to 59.09%. Now to find mean effective pressure, first we find V1 and V2. So as V2 is equal to RT2 divided by P2. So the value of R per year is 287 joule is equal to Newton meter per kilogram per Kelvin. T2 is equal to 850.8 Kelvin divided by 45. Pressure is equal to 45 bar, mean 45 multiplied by 10 power 5 Newton per square meter. So V2 is equal to, simplify this, 287 multiplied by 850.8 and divide by 40 multiplied by 10 power 5, which is equal to 0.05426, and this Newton will be cancelled with Newton, Kelvin will be cancelled with Kelvin, and meter square and double division will be in numerator. So meter into meter square is meter cube per kg. This is V2. Now to find V1, compression ratio is equal to 15 by 1. So this implies that V1 is equal to 15 multiplied by V2, and V2 is 0.05426 meter cube per kg. So V1 is equal to 0.8139 meter cube per kg. Now we can easily find mean effective pressure. Mean effective pressure is denoted by Pm, which is equal to area under the curve on PV diagram, which is net work, and V1 minus V2. So net work is equal to 636.75 kilojoule per kg. Kilo is equal to 10 power 3 and joule is equal to Newton meter per kg. Divide by V1 is 0.8139 minus V2 is 0.05426 meter cube per kg. So meter cube is equal to meter into meter square per kg. So mean effective pressure, simplify this value, so this will be equal to 838226, and this kilogram per kilogram will be cancelled with 1 kilogram. This is basically meter cube meter cube. So 1 meter will be cancelled with 1 meter. So this will be equal to Newton per square meter. Newton per square meter is equal to Pascal. Newton per square meter is equal to Pascal. To convert this into bar, divide by 10 power 5. So this is equal to 838226 divided by 10 power 5 bar. So mean effective pressure is equal to 8.38226 bar. And this is the end of the problem. So for more videos, please like and subscribe my YouTube channel and share with your friends. Thank you.